Good morning, good afternoon, good evening, and welcome to another episode.
Working on OpenShift
and sometimes we haven't.
This is so awesome.
We are an open culture that believes
It's actually
in
a big piece of the component for your GitOps work.
Everybody has something that they can say.
On top of the Red Hat portfolio.
Good morning, good afternoon, and good evening. You have lurched into another episode of the Level Up Hour. So thank you for joining us. Please make sure to like, subscribe, and share it. Let everybody know that we're out here on the air. I'm Randy Russell, Director of Certification at Red Hat. So shout out to all those Red Hat certified professionals out there. And I'm joined by my co-hosts, Jafar Charibi and Scott McBrien. Greetings, gentlemen. And
hi, everyone.
And so today we have a very interesting episode in which we're going to talk about pipelines as code. Okay, and to help us untangle that is Shmuel Bujna, who is the lead architect and developer of, guess what, pipelines as code. So I think this is going to be a very interesting episode. So first of all, let's talk a little bit about pipeline as code. Jafar, that's I think I'm going to back it up a whole lot and say, well, I think most of us at this point in time are familiar with the concept of a CICD pipeline. Continuous integration, continuous deployment, where you have your application, the new feature, the bug fix, whatever, and it is whisked seamlessly and effortlessly through test and stage all the way to its glorious end in production, right? So help me understand what we're getting at when we talk about pipeline as code.
Okay, sure. So again, I wanted to thank Shmuel for joining us here today. He will be explaining a bit more of the new features that we are offering on OpenShift, but to give some background to this. So we all know that traditional CI/CD tools have been evolving since we started using that kind of tools to provide some kind of scripted automation to do your pipelines. So basically writing what we call domain-specific languages, where you have some specific scripting like Groovy or whatever specific languages was used for that specific CI/CD tool. So basically, for example, if we speak about OpenShift and Jenkins, we've been providing something called support for Jenkins files, which basically is a Groovy script that orchestrates your CI and CD steps throughout the different environments. But as the Kubernetes ecosystem really boomed and I would say exploded, and it started to become the de facto infrastructure to run containerized applications. So I'm saying Kubernetes is the infra. Probably some people will throw some rocks or tomatoes at me, but basically, yeah, we can consider that it's the modern infrastructure to run those applications. And something that has emerged about 2 years ago, which is, could we think about Kubernetes also as a CI or CD tool? So basically, instead of relying on a dedicated CI tool like Jenkins, or I don't want to call out those tools because they are great and they are good at what they do, but like Jenkins, GitLab, or Travis, or whatever, those tools. So the goal was, can we have something that is relying solely on Kubernetes as the CI/CD engine? Can we extend Kubernetes to understand new concepts of CI/CD? And since the introduction of what we call custom resource definitions in the Kubernetes API, that allowed us to create some new concepts that were not existing in Kubernetes before in a simple way. So the key thing behind it is in a simple way. So basically, you can now tell to Kubernetes, here's a new concept, it's called a pipeline. Here's a new concept, it's called a step. Here's a new concept, it's called a task or whatever. And basically now Kubernetes starts to understand how to trigger and run pipelines natively by orchestrating containerized actions or tasks. And thus we don't need those dedicated CI/CD tools anymore. And one of the drawbacks, I would say, well, not drawbacks, but one of the things that you had to take care of was the administration of those tools. So now, since you are switching to Kubernetes, that's, I would say, less administration. So that's the first. It's more portability, because now you can have your CI running on any Kubernetes cluster that has those concepts installed. So basically, it's based on an upstream project called Tekton. And the great thing with Tekton is that it's all of those great CI/CD vendors, players coming together to come up with some sort of standard. So the standard way of pragmatically describing what a pipeline is, or what we call pipeline as code, right? So how can we write YAML files that translate into pipeline execution? So that was the whole idea behind Tekton. So that was to provide a Kubernetes native CI/CD ecosystem.
Right. So if you have a native, now that it's Kubernetes native, you get the benefit of not having some integration points that you might have otherwise. You have the consolidating down to a smaller number of technologies or products, in a sense, and potentially a smaller number of vendors, which is also sometimes a benefit. And then it is actually something that's native. There's something ironic in this, in that I think a lot of the world has come to Kubernetes and to OpenShift with the desire to build out their CI/CD pipelines. And it can be effective for that, but it has not actually been a native capability from the outset. So it's really interesting to me that now the purpose that so many organizations come to OpenShift is actually going to be supported natively. Would that be a fair statement to make?
Yeah, definitely. And so the interesting thing is that, so of course, Kubernetes is known for its scalability. You can now orchestrate thousands of tasks and pipelines, because Kubernetes allows you to have that scalability. You can dedicate. So you could do that before with the traditional CI tools by using what we call agents. So basically, you had to deploy agents, you had to administrate them, upgrade them, and all of those kind of topics. And also one of the things was, say you wanted to integrate now with a new set of tools. It's so either there's an existing plugin that you can rely on, and you just take it and use it, but you are limited to whatever the plugin offers, or you are a massive Java guru and you can, for instance, create your own pipeline. I have some colleagues who did that, but like, they are crazy guys, but they are very talented guys, of course. But now with the Kubernetes and Tekton way of doing it, it's basically you are creating container images that contain all the tools that you need. And then through the YAML steps, you are referencing those images and say, this is the command that you need to execute in this by pulling this specific image. So now it becomes much easier to extend the capabilities of your CI/CD ecosystem, basically. As long as you can put it in a container, it's going to be fine with your pipelines.
It is ready to go. Cool. So we actually already have a question in the chat, and Shmuel, I think a perfect introduction to your participation here would be to put you on the spot. So Shrikant asked the question is, okay, how do we manage pipeline as code when we have hundreds of microservices? And in brief, the answer is?
The brief is that you're doing integration testing. Is that so? First, like we need to maybe to explain like what's pipeline as code. I mean, Jaffa has done like a great introduction, like to Tecton pipeline and how you specify pipeline, like in YAMLs, and define your testing and the steps, the different steps for the testing. But pipeline as code itself, what it does is that you have a repository, like where you have some codes inside it, microservices, for example, like Sri was mentioning, and you want part of the development process. So when you're doing a change to your code, you want like to have your pipelines living with it. So you want like to be able that your change that's happening in your code like reflects what's inside your pipeline. So historically, and a lot of CI systems does that, is that like you install your pipeline before, and whenever there is like a code change, then it tests it. If you need to make a change to your pipeline, you go on the server, you change the pipeline. Here with pipeline as code, the basic idea is to be able like to have your code inside to have your pipeline inside your code. So whenever, like for example, like you're adding like a new component that needs like different kind of testing, different steps inside your pipeline, then part of the PR that you're going to send, like it's going to pick up like that same change, and it's going to take effect with the change of your code. So the question of streams is like how you do that, like when you are like, so as I said, like the repository like is very tight to the change that you have inside the pipeline. So the pipeline reflects the code. And how do you do that? Like when you have like multiple microservices, and usually it goes beyond pipeline as code. Is that it's how you're going to test your microservices. So to be able like to test your microservices, there is different techniques to do that. The like integration technique, integration test, and when you have like multiple microservices, you usually use contract testing. So you have like contracts between different components, microservices, and you just like making sure that they work to each other. So when you're going to write your pipeline as code pipeline, you're going to have like integration testing of those microservices put together, and every time you're doing like a PR to your code, like it's going to run those integration tests, making sure that your change is not going to break it.
Yeah, so thanks a lot, Shmuel. That's some great insight. And if in fact this question alone can be discussed for like the whole afternoon, because it's a very complex topic actually. I did a webinar on that specific topic. It's like CICD for microservices. It was a few months back. We can try to find the link and share that afterwards. But I think it's also a good topic to discuss because there are a lot of things that you need to address, both from an administration standpoint and from a developer standpoint or from a DevOps standpoint. So basically, one of the key aspects is because you are managing hundreds of services, these type of new pipelines allow you to have some genericity, something that can be reused across the similar applications. So for instance, if your application landscape is composed of 30% of Java apps and 50% of Node.js apps or whatever, so I'm throwing random numbers here, you can try to factor the Java apps into a similar pipeline that will allow you to just point out to a different Java repo and then build out the application with the same exact pipeline and then deploy that microservice somewhere. So what you really need to avoid at all costs is if you have 100 microservices to create 100 different pipelines. That's something that doesn't scale. It's not something that you will be able to manage. So the key, topic here is factor your pipelines and have something that is generic and that can be dynamically adapted to your microservice. So one pipeline definition can serve 30 microservices, for example. That's one of, I would say, the key aspects. Of course, what Shmuel mentioned, integration testing, contract-based testing, using things like mocks, when the microservices that you rely on are not still available in the testing process. So yeah, there are many techniques that we can maybe discuss. And yeah, Shmuel, I think you wanted to say something.
No, I just wanted to add to your answer. Is that it's like there's like, as you said, like there's so many things like we can talk about for microservices, but there is as well like how you're going to structure your code. It's like, are you going to have like multiple repository? Are you going to have like a mono repo? Are you going to have like a multiple repos bunched together? And the complexity is going to be enormous, like different ways. So a lot of people goes to mono repo kind of structure to be able like to solve those kind of problems. And then yeah, if you start like to have like 100 microservices, you'll need to think about like how you're going to move it like to a mono repo structure, because the complexity can be like really great if you don't have that.
Yeah,
well, you don't want to have 100 examples of pipeline as code is basically right what you want to end up not with.
Yes, yeah, exactly. That's
using
not what.
Using the earlier example, so you say, okay, well, so there maybe it's 60-40 Java to Node.js. What you're hoping is that in the perfect situation, maybe you have two approaches to pipeline as code. One is your Node.js approach, one is your Java approach. Maybe you have to subdivide it a bit more, but again, you don't want to have 100 approaches. And that might be the real challenge, is that in theory, it would be possible to do that, right?
Yeah. So also one of the key aspects of this pipeline as code or Tekton is the reusability of tasks. So basically, you can define shared tasks that users can reference. So basically, you don't have to reinvent the wheel for pushing an image to a registry, or for building code, or for doing integration testing, etc. So it's all there. It's ready on your shelves. You just have to reference it and say, please use this task in my pipeline. And that's how you can have some genericity. And that's how also how you can lower the barrier of administration when you need to make something evolve. So if everything is spread out into the 100 pipelines, then whenever there's a change, you will have to manually commit that to each and every one of those 100 pipelines. If you are taking the shared approach, shared tasks, or whatever you want to call it, you can factor the change into a single place, and then it's reflected in the 100 pipelines that are going to reference it. So there are many things that you can use to, I would say, industrialize the way that you build your pipelines, and actually would be happy to have another episode around this. One of the other things that we can leverage, or I don't know if we can say leverage something, but use as a leverage is GitOps also in the picture. It can also simplify a lot of those things. And it can also address what Shmuel mentioned, which is this notion of mono repo or multiple repo, where every microservice is going to have its own code. And then you have, if you are using GitOps, then you have to think about where you're going to store your GitOps resources and stuff like that. So organization and standardization are key topics that need to drive the conversation. And of course, it's not going to happen from just one guy deciding something. It needs to be taken into a DevOps approach where you have everyone thinking about the end, I would say the end goals and the best way to standardize the code, the repos, the pipelines, the testing approach, etc. So Yeah, I think we have spoken largely enough about that, and I hope
Covered the
that,
microservices.
yeah, exactly.
So let's back up a little bit, and for the benefit of Stabby and myself here, what needs to happen if you for an OpenShift administrator to make this capability manifest itself in an OpenShift environment, or is this something that the developers simply start doing and it works as though by magic?
Yeah, so of course, that's the end goal, is to make it appear magical for the developers and make it their life easier. And I guess Shmuel can talk in more details about the end goal of this. But let's dissect that into several things. So I will speak about the OpenShift pipelines. Shmuel can speak about the pipeline as code. I will just rephrase what he said to make sure that everyone is on par in terms of understanding what it does. So as an admin, first thing is you will have to install the OpenShift pipelines operator. OpenShift pipelines is our downstream productized supported offering, which is included in OpenShift based on the Tecton upstream project that we spoke about. So it allows you to basically define pipelines as YAML and Kubernetes native resources. Okay, so first thing you need to do is install the OpenShift pipelines operator. Luckily, we made that very easy for our OpenShift users. So as an admin, you can either go through the, I would say, operator hub and install it, or you install it through command line. So I can show you that once we go to the demo section. And then some things need to happen for the pipelines as code. So just to make sure, I'm going to rephrase what Shmuel said. So once we have the pipelines installed, what we want to allow our users to do is to ship the YAML of their pipeline in their application and don't need to worry about creating the pipelines in OpenShift beforehand. Because if you are using the traditional way, your code, even if you commit and push your changes, nothing's going to happen unless you have a webhook somewhere that triggers a pipeline that you have already configured before. So it takes several steps before this can happen. So let's say this is the traditional way of doing it. I create my pipeline in OpenShift using YAML or using the UI. So because we have a UI builder where you can basically draw your CI/CD pipeline. Then you create a webhook that your code repository will use whenever you trigger some events like a git push or git pull or something like that. And all of that needs some administration. You need to configure all of those things. So now switching to the TKN or pipelines as code, sorry, way of doing it. And Shmuel, if you would like, please to explain how it works and what needs to be done, that would be good.
Yeah, so as you explained, that pipeline as code plugs into OpenShift pipeline. So it's a feature on top of OpenShift pipeline that you can add, and to make it to make your to be able to do your CI directly from your GitHub or from other VCS provider like source code provider. So currently, pipeline as code is a dev preview feature. So it's not yet integrated inside the OpenShift pipeline operator, but we are working toward it. And it's currently the way it works is it's available inside the GitHub organization OpenShift pipeline, and where you have where you have some instructions how to install. So the thing is there's two parts to it, how to do the install. There is the easy part, which is applying YAML files inside the cluster, to get the capability. And the second part is is to be able like to say like to your source code provider like GitHub that all the events happening inside your repo, it's going to go like to the OpenShift pipeline cluster. So you need to be able like to say that. So to do that, like the main way is to create like a GitHub app. So that GitHub app is going to be central to pipeline as code, and it's how you're going to manage all the interaction between pipeline as code and your source code. So what I mean is like whenever like a developer is going to send a PR, pipeline as code is going to see it, and it's on the cluster is going to see that there is that Tecton directory inside your source code repo with a pipeline inside it, and it's going to see if it's possible to like if the cluster wants to like has information about it. So if we are able like to run it or not, and then if the user as well is allowed as well like to do that, and then it's going to run it, run the pipeline as defined inside your source code. So at the point of time of your PR, and then it's going to report, like it's going to do a nice report of all those things that has been failed or has been successful, and with link to the logs to the OpenShift console. So that's the basics of it. And there is multiple features of pipeline as code around that to make it easier to develop a pipeline as code pipeline, and which sits on top of OpenShift pipeline. So we have like different like capabilities, like for example, we have like what we call like chat ops capability. So you're able, like for example, like when you have like an issue with your infrastructure and the pipeline is failing due of that reason, you can just like do like a /retest inside your PR itself, and it would like restart like the process. And you can do like different things like for allowing people. So by default, like try like to make sure that we don't allow anyone like using your infra. So not everybody can send a PR for anything, but but someone who's allowed like can just do like a /OK to test, and automatically like you'll have like allowing this. There's other features as well to make it easy. So by default, something that's not possible to do with OpenShift pipeline, vanilla OpenShift pipeline, is to be able like to get task that's not cluster task, or that's not like task inside your namespace that's already installed. But with pipeline as code, you're able like to say like I want to pick up that remote task from somewhere else, or from the hub, the hub, which is like a catalog of all the tasks that has been contributed by contributors, and automatically it's going to you can use it inside your pipeline without having like to pre-install it or to reference it from somewhere else. And that's the other question that we had previously that we were talking about. Is like it makes it like as well even more easier to share your different tasks because you can just like have a simple URL now, and you don't have like to install it. So that's some of the features that you have with pipeline as code. And I think part of the demo, it's going to be a bit more clear, like how the flow looks like, and how you can do a PR and iterate into it, and after be sure that it's green or not.
Yeah, sure. So thank you, Shmuel, for the I would say this transition. Should we maybe go to the demo to
it's the four-letter word?
Yeah. So it's going to be more visual, and afterwards we can talk about what happens in the background.
What could possibly go wrong?
Live demo?
Yeah, exactly. Yeah, live demos. Well, what can go wrong, right? Yeah. All right. So first step is I need to succeed in sharing my screen. So that's the first step of a successful demo. Can you guys see the screen correctly? Is it fine?
Yes, we can. Yeah, it's good.
Okay, cool. So yeah, let me try something real quick here. Okay, so I have an OpenShift cluster here where I have a Node.js application. So where the goal here is to keep it very simple. Let's have a look at this app. Okay, that's our OpenShift starters. It says version 2.32, pipelines as code. Okay, this application runs in a namespace where if we look at pipelines, I have no pipelines defined. So traditionally, if I wanted to have CI/CD for this application in this project or in another project, the first prereq would be to have a pipeline that is defined in the namespace. And then I would execute the pipeline by creating what we call pipeline runs. And if we refer back to what I said about having something that is generic, the pipeline definition is the generic aspect of it. And the pipeline run injects some data to say, here's the Git repo that you should use as an input. Here's the output image that I want you to generate and stuff like that. So, okay, we have our image. We see it's version 2.32 here. And let's have a look at our repo. So to speed up things for the demo, I have already created a pull request. And the flow that we're going to look at is I have this specific pull request that is open, right? And basically, I can use it as a conversation with all the developers. So whenever I'm committing a new change to my application, I want some CI/CD process to be triggered automatically so we can iterate, etc. And once we are all satisfied, we can ultimately merge the pull request into the main branch or something like that. So I have a new branch, which is, I would say, our feature branch. And afterwards, I want to merge my code changes into the master branch, or sorry, we should say main branch, but I haven't updated the terminology since then. So, okay, let's make some very quick changes to our code. So I'm opening up my IDE here, and basically you can see I have version 2.33, and I'm going to say it's the level up our change. So now I'm gonna commit my changes here, say changes. I like how it sounds. It's funny. So the and then I push my changes and wait for something to happen magically. So as a developer, this is what I do. Let's watch what happens in here as the commits get coming into the repo. So this will trigger some magical things that we are going to talk about in the background. And now you see in the GitHub interface, I have some indication that the pipeline as code has been triggered and that it's running a CI/CD pipeline. So the interesting thing is that directly from OpenShift, I can see the status, I can see that it's running, etc. And I can also look at the details directly from here. So when it's finished, I'm going to have the summary. If I wanted to check the logs directly from my terminal, I could just run this command. And oh, I'm not logged in, so I need to log in there first. But let's go back to the UI and have a look at the pipeline. So, so here from the developer perspective, I can see that it's running. It's been triggered recently. It's doing the build steps, etc. And just to make it easier for me to consult, to see, I have added this notion of pipeline runs into the developer perspective. So just a very quick tip for people who are looking at this. So say you are using a concept of, I would say, image stream tag that doesn't exist by default in the navigation bar on the left side. You just say add it to navigation, and then on the developer you have a new item that shows you the things that you need. So that's what I did for the pipeline run, and I see now that the pipeline is being executed here. So for the sake of time, let's go back to some of the previously run instances. And actually what happens is once the pipeline has succeeded, the pipeline as code feature from OpenShift updates GitHub with the results, the build times for each step, etc. And I can have a direct link from here to the task if the logs are still there, if they haven't been erased, etc. So you see that directly from the GitHub, I see the status, I get directly to the logs, etc. So very nice feature. I love it, Shmuel. Very good job, guys. It's much easier for developers to trigger the pipelines. I don't have to create my webhook in the repo and select the events, etc. So very nice, and thank you for making our life, if I'm impersonating the developer, life easier. All right, so other things exist in this extension. So let's go back to how it works. So basically, within my repository of my application, I have some files that have been defined. So I have the pipeline as code that you can see here, and it basically describes the steps that are going to be executed. You see that I have the first task that is fetch repo. Second task is build the application to store the container image. And last task is going to be deploying the application somewhere. I can see it, but yeah, deploy the app. So very simple steps in my pipeline. Now, whenever I trigger an event, so on our case, we were speaking about a pull request, right? So the pull request, sorry, it's not this file, it's a different one. Yes, so I believe it's this one. So the pull request, the pipeline run injects the data that I need for the pipeline to run. Basically, it tells where the repo is, what branch I'm going to pull the code from, etc., what output, etc. So here I've done some static things, but basically what's very interesting here is on what type of events am I going to be triggered. So here in my code, in my application repo, I have a file that says whenever you intercept a pull request configured for this specific repo, and we're going to see how we configure that, please trigger this CI/CD pipeline run. And the pull request needs to happen on this specific branch. Okay. You can also trigger on different events like a push. If I'm doing a git push, then trigger the pipeline. And if I'm doing the pull request to a QA, then trigger a subset of the pipeline. If I'm deploying to production, maybe do something more elaborate, etc. So basically, you are defining the how, like so the when, which is basically on what type of events are you going to react, and you are defining the what is going to happen in the pipeline. So basically, that's the magic behind it. You have, so there's some kind of structure. We spoke about this notion of structure in your repo if you want to provide some kind of magic. And that's basically what we decided is that you have to ship a .decton folder inside your repo. And this is what is going to be triggered. So now, before all of those, this magic can happen from the developer perspective, some other things need to be done in the background. And that's basically what we are going to try to cover for the remaining time. Just before that, some very nice features that I like that Shmuel mentioned. So yeah, we see that the pipeline has finished. Everything looks fine. It's all green, all good. You see that it's been run just now. We are not like doing smoke and mirrors here. It's live stuff. And now say I have published something else or whatever, and I want to retest basically a specific PR. So I just submit the retest comment, and the pipeline as code is going to intercept that, and basically it's going to trigger the pipeline again, even if I didn't specifically make my commit or whatever. So very nice feature. I love it. Again, Shmuel spoke about some more advanced workflow features where you can approve the PRs, like okay to whatever, okay to test, I think, or something like that. So yeah, that's, I mean, I love it. It's advanced. It's not something that we provided with the previous tooling. We didn't have that, I would say, two-way integration where from OpenShift, you do some stuff in GitHub, for instance, and then get your results back in OpenShift itself. So it's a two-way integration, and I just love it.
So if we could for a moment, Jafar, love the demo. We did have a couple of questions come in that
sure.
that I thought we might want to turn our attention to briefly here. And so the first question was, is it possible to deploy the resources to multiple namespaces, or pipelines limited to deploy resources in the namespace which the pipeline is deployed?
Yeah, so that's a great question. Yeah,
Shmuel?
I don't think that you are. Sorry, Jafar.
While no, that's
the architect of this.
No, I don't mind either way. But it's just that maybe something that we didn't spoke about because it's a bit low level is that like when you have like the way it works is that you have like to be able like to say that your repo is going to be handled by pipeline as code on that cluster and on which namespace. We have what we call like a repository CRD, so a resource, a custom resource called repository, and that's going to say that I want to be able like to handle that repo and coming. So whenever like there is going to be events coming to OpenShift pipeline and coming from that repo, it's going to be tested in that namespace. So in that case, it's like when you start, like it's only going to start on that namespace. But then if you want like to use like two different namespaces, you can have part of your pipeline as code step. You can have like a deployment step or like something else that's going to be able like to deploy on another namespace. But then you're only allowed to do that if you have like some rules, RBAC rules, to say that this user is allowed to deploy on that other namespace. Because obviously you don't want to allow to do to have everything, to allow to have access to everything on the cluster.
Yeah, correct.
That's like
and so basically, yeah, that's a mix of yeah, you are going, for example, to use service accounts, dedicated service accounts to do subsets of your pipelines. And whenever, so for example, for me, in a previous demo, I was doing the build in a different namespace, and then I was deploying in this namespace. But just for the sake of simplicity and avoiding to switch back and forth, I put everything in the same namespace. But what you have to do is to give that service account the correct role to be able to do whatever it needs to do in that namespace. So for example, if you want to build and push the image to a specific namespace, then you have to give it the edit role or something like that. Or if you want to deploy, you would need to give it the specific rights using the OpenShift role-based access stuff. So
I think the answer I'm discerning is that it is yes, but it's not something that it's going to actually require a bit of user and access control, and you're going to want that because to the earlier point, you don't want it to be the case that something can simply be leveraged, and the next thing you know, there are things coming into your pipeline that you never expected to have coming into your pipeline, right?
Especially with events coming from the internet, you really don't like to let everything happening there, right. And with all the miners and all that stuff.
Yeah, that might be a problem. So we had another
So-
question too, going back a little bit. The deliciously named bacon fork was posing the question of what kinds of things can you check for, and this was while we were, in the demo, and so we might have to rewind our brains a bit here. What kinds of things can you check for? And I guess I would say it probably depends on the particular point in your pipeline that you're talking about.
Yeah, so I'm not sure I completely understand the question, but basically you are defining in your pipeline whatever events or whatever tasks you want to trigger, and this is what is going to be checked within the pipeline. So if for some reason a specific task fails, so meaning one of your checks, because basically a pipeline is a set of checks and actions. So I'm doing something, then I'm checking that what I wanted happened. If it happened, then I go to the next task. If not, then I fail miserably my pipeline and say, okay, so please go ahead and make changes to whatever. So yeah, each step is going to be, I would say, a check in itself. Because it's using Tekton, you are going to define whatever tasks. You are going to reference tasks that you have built on your own or that you have pulled from the public hubs, and then you are going to use them in your pipelines. I hope I understood the questions correctly, but yeah, that's my honest answer to what I understood.
And you're sticking with it.
Maybe if you
Stabby?
didn't understood. Yeah, so I was just adding, like, maybe if you didn't understand the question, and the question was about what kind of events pipeline as code can handle, and but
Okay.
like, and in that case, like, that's a good information too. It's like we handle the events of push and pull request. So that's the two events that's handling, and you can do that on the different branch, like we say main, master, whatever, and release tags if you wanted. So if you want like to launch a pipeline, whenever you push to a release for a tag, then you can handle that events too. So that's just like to add to it in case that was what the user was meaning to ask.
All right. So Scott, you actually had a question, and you are on air. You do get to just speak up and ask, and you don't have to type them in the chat, dude.
Indeed, but I wanted to make sure that I didn't forget to ask it. And then also, I was kind of in the middle of Jafar's demo and I want to interrupt his flow.
There you
So,
go.
so just sorry, I said I was going to show also some of the cool things that they built for the admin side of it. So there's still another set of demos that I wanted to show, but yeah, go ahead, please. And
I promise we will come back.
I'll try to push whatever I can in the demo.
So
You're gonna have to talk really fast.
get to ask my questions.
Yes, speak.
Yeah, go ahead.
So, rolling back to the beginning, I just have a more rudimentary question about the integration with GitHub. So did you guys set up a webhook so that the operator is triggered by the webhook, or does the operator just like do something
Thank
weird?
you. Thank you very much, Scott, for the question, because that's exactly what I was going to show. So
All right.
the clever guys, so I hope it's going to work, because I'm switching to a completely different cluster that doesn't have it installed, and I hope it's going to work.
A new live demo.
Yeah, a new live demo. Let's take risks again, and
What could possibly go wrong?
and see if we make it alive. So
all right, well, so let's go to that demo. We did have some more questions, and hopefully we can maybe come to them at the end. But I am eager to see this.
All right. So first thing, so as a prereq, as I said, we need to have the OpenShift pipelines operator installed, and that needs to happen so you can do it for example from the operator hub. So OpenShift operators. So I see that we have the pipelines operator that should be installed. yeah, so we see that it has been already installed in this cluster, but the pipeline as code shouldn't exist, or if it does, we are going to delete it, like savagely delete it. So I'm on a different cluster, right? And let's remove it and show you how. No, that's not what I want to remove. I want to delete pipelines as code, and it's not there, so that's good. All right, so that's what I thought, because I had taken care of that. Now let's go back to our terminal, and we have some nice command line called tk-unpack. And tk-unpack is for Tekton. So we have the Tekton CLI, which is tkn, and we have, I would say, an extension of it called tk-unpack for pipeline as code. And one of the options that you have is the bootstrap. And the bootstrap is basically taking care of all of those background things that you said, that you mentioned, Scott, and that you need to do as an admin, is basically enable the feature on the cluster. So let's try it, and hope that Shmuel did some good job on that. So
No
first
pressure.
thing, yeah, no pressure. I mean, if it doesn't work, that's not my fault, right? So I have to mention, speaking of that, that Shmuel has been amazing in terms of support. So, okay, let's go ahead and install it. And basically, we were on Slack, and I'm trying some funky things. And I ping him on Slack and say, you know, the application or this stuff doesn't work. He says, okay, please remain there. He makes some weird changes on his like code. He pushes and asks me to try it like 20 minutes afterwards, and it works. So amazing.
No, so basically he is your CI/CD pipeline.
Yeah, exactly. No, I mean, he's making changes to the pipeline as code plugin.
Pipeline as code use pipeline as code to do the development. So it goes much faster, the feedback loop and everything.
So yeah, we're going to create a GitHub app called Cleh app. And it says, okay, I have detected that there's a route that is going to intercept all my events, etc. And look at the cleverness of these guys. They have created an automated way for us. Oh my God, I have to log into GitHub and I have my two-factor stuff. So yeah. Okay, create the GitHub app for me. And whoa, it's there, magic. So now I have my GitHub application that has been created for me. And this is basically what is going to intercept all of those funky events. So first thing, that's a conversation we had yesterday. If you are using, so basically, yeah, the app is here. Before using it in the repo, let's have a look at some of the things. So yes, it points back to the interceptor that we have on our cluster, right? And now it says enable SSL verification. I am not using trusted certificates on this home lab. So yeah, I'm just making sure that I'm, I would say, yeah, not using that setting. Now, if I go back to the main app, I can now install the application, and I can choose what repo I want to install it on. So I can say, push it to all my repos or only to some specific repos, and then it's going to intercept those events. And it's the equivalent of creating all the webhooks for the concerned repos, except that it's one single entry point that you create, and that can take care of that that magic behind the scenes. So all went well for the enablement of the feature on the new cluster. And if I check for as code, I should have a new project here, and maybe I have also my running pod in there. So yeah, great. The interceptor is working fine. And now if I use that application in a repo, it's going to create the pipelines on this new cluster, even though I haven't created pipeline definitions on my namespace. So
just quickly,
yeah,
just quickly, because I know we're going to go out of time, is that there is a lot, like with Bootstrap, like the thing like makes it easy is that it makes like a lot of manual steps like automatic. So it's going to create like a secret on the cluster, and it's going to manage and do a lot of things. So that's a quick way to get you started. So the end goal actually for as a product is to make it part of OpenShift pipeline. But TK Impact Bootstrap is mostly like if you want to get started and to get started and be able to try it on. And there is as well all the manual step that's referenced in documentation if you really wanted to go that way. And hopefully we are working to get the operator. So a lot of the steps are going to be handled by the operator. But some part of it, like the creation of the GitHub apps, which actually we implemented this because we had a lot of because before we didn't have this, but a lot of people were making were not checking like the right case, like when creating the apps. It's really tedious manual process.
Yeah.
But so that's why we made it.
I
We
can
made it so
testify.
it takes like. Yes, I had a lot of bug reports and people bug me about it. So, but now it's like it makes like literally, if you want to try on Python as code, you just need to go to the webpage and download the CLI, TK Impact Bootstrap, and as long as you have OpenShift cluster and a GitHub account, then you'll be set to go.
And the pipelines operator.
Okay, so yeah, let's make sure we've got the list together here. You're going to need the pipelines operator, and then we're also going to need, what was that package again?
The TK Impact CLI, which we can
CLI.
drop.
So if we can maybe drop that in the chat just so that people know, because I think there's going to be a lot of interest in being able to do this, being able to have that single view into this within OpenShift, to manage it within OpenShift. I think just the more I think about it, the more beneficial it starts to appear. So we did have a couple of other quick questions. First of all, as always, there's the question about what are the resource requirements to implement this? Is it going to be part of my same namespace or cluster?
So that's the beauty of it, is that there's no resource requirement extra. I mean, the way we designed
there's no incremental resource requirement beyond the OpenShift deployment you already have.
That's correct. So pipeline as code is implemented as OpenShift pipeline. So there is no daemons. They're all using internal components from OpenShift pipeline, which is a triggers component, task pipeline. So you don't have you don't need to have a special deployments and it's going to have daemons and things. And so it is that it only going to react to events coming from outside, and it's going to use what we call event listener, like a tecton trigger event listener, which is built inside OpenShift pipeline to be able to handle those events. So there is no extra requirement, resource requirement.
Great. And so I think another question that we had was, can you share with us a holistic view of each stage of the pipeline? And so I'm wondering if perhaps we have a link or web resource that we can point someone towards.
Yeah, so I would say, so sorry to phrase it that way, because I'm not a native English speaker, but I don't think the content of the pipeline itself is meaningful, because basically I've done a very simple pipeline to show build the code, build the container image and deploy. So basically very simple stuff. But we have a lot of other more sophisticated and more meaningful Tecton pipelines that we could show you, maybe if it makes sense, as another episode. Where basically we do all the stuff like CI, we use Sonar, we use unit tests, we use integration tests, we use code coverage, and all of those funky stuff, and security code scanning, and
So basically there could be a lot of different stages, and that's the beauty of this, is that you are with the code literally defining what all of those stages might be. And it might be that you have a very simple, naive one-stage model, for the purpose of a demo, or something a bit more than that. Or you could actually have something that has quite a few different stages because it's required by your particular app, or governance, or compliance, whatever kinds of things might be in the picture that need to go through a much more staged process. And so I guess it's, in a sense, the answer to that question is the holistic view is whatever you choose to actually build as your pipeline
to put in there. Exactly. Yeah.
Very cool stuff. Well, let's see. Do we have any other questions or closing comments? Shmuel, it looked like you had
just need to add something. Is that about OpenShift console? I don't think Jafar had a chance to show it because it's part of OpenShift 4.9. So on OpenShift 4.9, on the OpenShift console, we have an integration, like a visual integration of the repositories, like of pipeline as code. So basically, if you have like pipeline as code installed on OpenShift 4.9, you'll get